In this lecture, we will go ahead and talk about Marshallian demand for Cobb Douglas functions. Let us go ahead and let us write down a typical utility function, a Cobb Douglas utility function, say x to the power alpha, y to the power beta. To find the Marshallian demand of a well-defined IC, we know that we must go ahead and we must find out the tangency condition between the IC and the budget line. By tangency, I mean that the slope of IC and budget line should be equal. Now, we know that the slope of IC is called MRS and the slope of budget line is called PX by PY. So we want MRS to be equal to PX by PY. MRS can be given by MUX by MUY. PX by PY remains the same. Now consider your utility function. U is equal to x to the power alpha, y to the power beta. MRS for this one will be MUX by MUY. When you differentiate this with respect to x, you will get alpha, x to the power alpha minus 1, y to the power beta. When you differentiate this with respect to y, you will get beta, y to the power beta minus 1, x to the power alpha. Note that this can be rewritten as alpha by beta into y by x. Right? I must equate this MRS to the ratio of the prices, Px by Py. From here, I will get y is equal to x into Px by Py into beta by alpha. We know that whatever point of equilibrium we get, it lies on the budget line. So it must satisfy the equation of the budget. What's the equation of the budget line? Px into x plus Py into y is equal to income of the consumer. So we get Px into x plus Py into, instead of y, we will write this, is equal to n. Note that this Py and Py is getting cancelled. I can take Px into x common and I will get this. Therefore, we will get Px into x, alpha plus beta by x is equal to n. So x star will be alpha upon alpha plus beta m by px. This is the demand of good x at the point of equilibrium, at this point. Why is it called Marshallian demand? It is called Marshallian demand because it is a function of income and prices. Since it is a function of income and prices, therefore it is called Marshallian demand. Right? Now, y star can also be found out by putting it again here. Y is x into px by py into beta by alpha. So this is going to be alpha upon alpha plus beta m by px into px by py into beta by alpha. Alpha and alpha get cancelled out. Px and px will be cancelled out. So it will be beta upon alpha plus beta m by py. So y star will be beta upon alpha plus beta m by py. So this implies that at the point of tangency, here is my equilibrium. X star will be m by px into alpha upon alpha plus beta. And y star will be m by py beta upon alpha plus beta. These would be the Marshallian demands of a Cobb Douglas utility function. Okay, thank you.